If you're an engineer or a researcher, you already know how powerful COMSOL multiphysics is. You probably also know the incredible pain of trying to run it on the wrong machine. Well, in this explainer, we are going to find the absolute best laptops to tame that beast and keep your simulations running nice and smooth.
Oh, we have all been there. You're hours, maybe even a full day into a really complex simulation. The deadline is staring you down, and then it happens. The screen just freezes, the program crashes, and all that progress, gone. It's a uniquely frustrating feeling, but it's a huge flashing sign that your hardware just can't keep up.
And really, that's the heart of the problem here. COMSOL is not like Microsoft Word or your web browser. It's a high-performance computing tool, basically a supercomputer in software form, designed to solve incredibly complex, real-world physics problems. And it demands a machine that is built for that specific kind of heavy lifting. Using the wrong tool for the job, well, that just leads to delays, errors, and a whole lot of headaches. So, let's frame the challenge properly. What are we actually trying to solve when we pick a laptop for this? You know, whether your specialty is something like computational fluid dynamics, simulating how air flows over a wing, or you're deep into electromagnetics, the core challenge is exactly the same. These simulations are solving millions of equations at once, and that requires absolute stability and sustained performance. You need a machine that can run at full blast for hours, sometimes even for days, without breaking a sweat. So to find that perfect machine, we need to understand what actually matters under the hood. So let's pop the hood and decode the hardware components that are going to make or break your COMSOL performance. It really boils down to these four things, these four pillars. If you get these right, you're golden. But if you get even one of them wrong, you create a performance bottleneck that holds everything else back. We're talking about the CPU, the RAM, your storage, and the often overlooked hero of the story, your laptop's cooling system. First up, the CPU. This is the absolute heart and soul of your COMSOL machine. The solvers are totally CPU-driven, meaning this is where all the heavy lifting happens. Now, what's really important to understand here is the need for balance. You need high single-core speed for certain operations, like meshing, but you also need a high number of physical cores for parallel processing, which is what really speeds up the solution time. Next up is RAM, which is basically your digital workbench. When COMSOL solvers build that gigantic matrix of equations, it all has to live somewhere, and that's in your RAM. The bigger and more complex your model, the more memory you need. Simple as that. 32 gigs is a solid entry point for sure, but for serious multiphysics work, you really want to be in that 64 to 128 gigabyte range to keep your system from just choking.
Then there's storage. Look, a fast NVMe solid-state drive is just not optional anymore. It's non-negotiable. COMSOL generates enormous temporary files while it's solving, and a fast SSD means the system can read and write that data almost instantly. So the key takeaway here is this. It's not just about how much storage you have, it's about speed that translates directly into time you get back in your day.
And finally, the unsung hero, the stability engine, your cooling system. A crazy powerful CPU is completely useless if it gets too hot and has to slow itself down to avoid melting. That's called thermal throttling, and it is the mortal enemy of long simulations. A really robust cooling system ensures your laptop can maintain its peak performance for the entire solve, not just the first 5 minutes.
All right, enough theory. With all that covered, let's get to the fun part, the machines that actually put it all into practice. Here are the top performers for running COMSOL.
First on our list is the Lenovo ThinkPad P1. You could think of this as the choice for the engineer who needs a near-perfect balance of serious workstation power, professional build quality, and at least some portability. It's just a fantastic all-around workhorse.
The pros are exactly what you'd expect from a ThinkPad, right? It's incredibly reliable, it's powerful, and this is a huge plus. You can actually upgrade the memory and storage down the line. The main trade-offs? Well, it can get pretty expensive when you spec it out, and like any real workstation, the battery isn't going to last very long when you're actually pushing it hard.
But what if you don't want balance? What if you just want maximum, no-holds-barred, uncompromising power? Well, for that, you're going to turn to the Dell Precision 16. This machine is purpose-built from the ground up for the most demanding simulation engineers out there. Its advantages are crystal clear. It has superior cooling for rock-solid stability, a massive RAM ceiling that can go up to 128 gigabytes, and tons of configuration options. If your work involves giant models or multi-day solves, this machine is basically your safety net. The downside, of course, is that all that power makes it heavy, not very portable, and yeah, it carries a very premium price tag. Now for something completely different,
The Apple MacBook Pro, with its Apple Silicon chips, represents a totally different philosophy. This is for those of you in the macOS ecosystem who really value a cool, quiet, and incredibly efficient work environment.
And this really highlights its unique place in the market. The single-core performance is fantastic, the battery life is just unmatched, and it runs almost silently even under load. It's brilliant for setting up your models, for post-processing and visualizing results, and for mid-size simulations. However, it's probably not the top choice for those truly massive CPU-bound solves. And remember, and this is a big one, what you buy is what you get. It is not upgradable.
Okay, but what if your work is super visual? If you spend a lot of your time plotting results, rendering animations, or wrestling with really complex 3D meshes, then the MSI WS and Creator Series laptops are basically designed with you in mind. Their main strength is that they pack in high-end GPU power, which dramatically speeds up the visualization side of COMSOL. And they couple this with strong cooling to make sure that performance doesn't drop off. The trade-offs are that they can be a bit on the heavy side and, well, the design style can sometimes borrow a little bit from their gaming laptop cousins, if you know what I mean.
Okay, so this slide right here is basically your cheat sheet. It lays everything out for a direct head-to-head comparison. You can quickly see the trade-offs. The Dell offers the most RAM for those truly massive models. The MSI gives you that high-end GPU for heavy visualization. The ThinkPad hits that perfect professional balance. And the MacBook excels in efficiency for those mid-sized simulations on macOS. Go ahead and take a moment here to see where your specific needs align.
Okay, we've seen the hardware and we've seen the top models. So, how do you actually make a decision? Don't worry. Here's a simple 3-step framework to guide you to the right choice.
First, and this is the most important step, you have to be really honest about your typical workload. Are your models huge, or are they pretty moderate? Next, based on that answer, pick your core components. A top-tier CPU, enough RAM so you're not constantly hitting a wall, and a great cooling system to keep it all stable. Finally, spec out the rest. A fast SSD is a must-have, but a powerful dedicated GPU, that's really only necessary if your work is highly visual. And all of this brings us to our final and most important takeaway. How do you find that perfect machine?
I'm going to say that again because it's that important. Choosing the right laptop for COMSOL comes down to one thing: knowing your workload. There is no single best laptop for every single person. The best laptop is the one that is perfectly matched to the demands of your specific simulations. A Dell Precision might be total overkill for someone doing smaller studies, just like a MacBook Pro might be underpowered for someone tackling massive, complex assemblies. Know your work, and the right choice becomes obvious.
And at the end of the day, that's what this all comes down to. Your work is important, and the tools you use should be empowering you, not holding you back. So as you look towards your next big project, your next big idea, ask yourself this question. Your hardware is the foundation of your research. Make sure you're building on a strong one.